Hey, Blogosphere. I saw Stefan Gotteswinter build a slow-speed grinding machine a little while ago, and I thought it was a useful tool to have, so I built myself a cheaper, crapper version. Let's break it down and see what's what. So you can get these diamond flat lapping discs for fairly cheap in a few different grits and sizes. This one's 150mm OD with a 16mm central hole, and you can get 100mm OD with the same central hole as well. Now on Stefan's, he drilled drive peg holes through the disc and then held it on with magnets. But I don't have any way of drilling drive peg holes in the same place every time for when I want to replace the disc. So I decided to try and hold it on and drive it with the same feature, which is this expanding conical mandrel. So with this bolt done up, it's all locked in place. If I undo this just a little bit, the disc becomes loose and I can take it off, revealing the platen. This is just 3D printed. I could have turned this out of wood, or you could turn this out of aluminium stock if you wanted to, but this is plenty strong enough. It's only like 10% infill as well. This is fine. So both drive and attachment are achieved with these two pieces, this being by far the most complicated. It's got a plain and a tapered section in the back, which pick up with the shaft of the motor, which has a serrated taper, and this is a front windscreen wiper motor of a Mercedes C-Class. It's got a plain section which registers on the inside of the platen, and then it's got this expanding mandrel section at the front, which has got a reduced diameter, and then at the very last bit it tapers back out to a 16mm OD, so that when expanded it grips the inside of the disc and just ever so slightly pulls it onto the platen. And expansion of this is done by this tapered section on the inside and a tapered nut. And all of this is a short section of M8 countersunk bolt threaded into a threaded machined tube. And that picks up on the front of the motor. Obviously, using just one fixing here doesn't provide the absolute best job of holding the shaft onto the motor and the disc onto the mandrel, so it is possible to make it slip round, but you don't need a lot of force when you're using one of these. You only need to press it lightly against here to cut the tiny last little bit of microbevel that you do on this kind of disc. This works absolutely fine, no need to be fancier. Of course you can use this freehand, but it's good to be able to hold a tool at a particular angle, so there's a table that goes on the front, and it's got a stay on one side that you can lock in place once you've set your angle using a protractor. On the back there's a dirt simple power supply built out of junk I had lying around. It's nice to not have a switcher, because if you load it down too much it'll just slow down, it's not going to trip out on a current limit. This is good for about 25 watts, which is plenty. It's got a switch on top to change the direction should you want to do that. Obviously it's got a little bit of run out. I didn't do a particularly amazing job of machining these central parts, but for my purposes more than good enough. And if I made this again I'd probably get it a bit better and it would run nearly true. But yeah, that's it for now. I hope you found this interesting. I'll probably put the plans for the important bits on the internet, blog post or Thingiverse or something. So leave a comment if you're interested, or look in the video description to see if I've already done that. But for now, thanks for watching, mash the buttons, and I'll see you soon. Bye for now. So my question to you is, would a chicken like a tomato? Turns out yes, a chicken would like a tomato.